for this introduction, and thanks a lot, François, to be here. May I just introduce you and your work in Turkey for everyone to know where we are. So again, thanks a lot to spare this time, and also the time you just told us to spend to find some information about COB and earthquake. That will be very important for us. So
very, very few things.
But better than nothing, always. So thanks a lot. And so please, whenever you're ready, you can start.
Okay, so thank you for inviting me to speak about COB. So I will just share my screen. Should works. Is it okay for you?
Yes, it's okay.
Yeah, okay, perfect. So I will first start to speak about COB heritage and then focus more on modern techniques, and especially on COB Bauge, which is a research project I've been working on since 5 years now. So just to start with the COB techniques, I know from Matthieu that you've got less samples in Turkey. So just to introduce you the techniques and the main characteristic of these techniques. So it's a techniques of massive earth wall. We call that COB in English. It's Bauge in French. So it's a mix of soil, clay soil most of the time, with less gravel, less sands, lots of clay and silt in it. Some fibers most of the time, especially in Europe, less in Africa, where they got some problem with termites. But in Europe, we used to put lots of fiber in it, and some water, which allow us to have a mix in a plastic state, so something very sticky and fresh that we can build with. So usually we works with a fork, and most of the time without any formwork, as you can see on this picture. So the mix most of the time is produced by animals or a human, and then implemented on the wall directly with a fork. We just built a first layer of this mix of COB, a layer that is around 50 to, let's say, 1 meter high when the soil is very good for that. But most of the time it's a highness around 50, 60 centimeters high, that we will let dry very few, so 1 to 2 days before we cut the face of the wall with a specific tools we call the parloir in French, which is something used to pare or to cut or to face the wall. So it's a kind of spade, as you can see on the left of the picture, that allow us to cut at the final size and shape the wall. Then the wall is tightened with a boner, which allow us to fill all the small gaps, small holes, which can appear during the cutting process, and then we will let this wall or this part of the wall drying for 2 to 3 weeks, depending on the weather condition. And when it's dry enough, strong enough, we can rebuild a new layer, as you can see on the right of the slide. We've got another technique which is very close to COB building. We call that gazon in French. It's quite similar. The thing is that it's not an amount of this mix which is implemented with a fork. We just prepare the mix in a sort of thin slab that we will cut to produce some fresh bricks that are implemented and juxtaposed each other, and as they are not dry, they stick together, and that allow us to produce that kind of wall that you can see here with that implementing process, like fish. I don't have the word in English, sorry, but you can see the shape changing from one layer to the other. So that's another way to build sort of variant of cob. Just here, just a small map showing that these techniques is most everywhere in Europe. It's the brown, the dark brown here on the map. So mostly in France and UK and Ireland, but we can find some in Estonia, Lithuania. We can find some in Poland, in Germany, Italy. Few samples in the south of France as well. And so a technique which is really spread everywhere in Europe, and probably one of the most ancient earlier techniques with wattle and daub that we can find in Europe. In Normandy, so it's really the cob can be used as a predominant material on construction, as you can see on the left pictures, or it can be used as an additional material on stone masonry for barns, or just to elevate the stone walls a bit more. But especially in the marshes of Cotentin and Bessin, so in the middle of west part, sorry, of Normandy, we've got huge building, and old building. Most of the one you can see here are from the 16th, 17th century and still existing, made with cob. Small farms as well. We've got around 10,000 of those buildings here in this small part of Normandy. So probably we are around twice this amount if we take all the region of Normandy. Lots of small buildings for the farm, bread oven, or building to press the apple to produce cider, or for honey and bees, as you can see on the bottom right of the slide here. These techniques, as I told you, can be found in the north of France. Here, a few samples coming from the border with Belgium. We've got some samples in Belgium as well, but the other area where we can find a lot of cob building is Brittany. Sorry, I forgot to translate the name here. So Brittany in the west of France, as you can see on the small maps here, where you can find some dwellings from the 16th century. Like this one, lots of farm as well from 17th to 19th century. Mostly those buildings were built between the 18th and 19th century. Lots of farm as well, so huge building for 2-story, sometimes 3-story. In Brittany, this building, for example, on the left is a 3-story building, but well, cob is really used. We've got the same amount of building in Brittany, around 20,000 of those buildings still existing today. So it'd be like in Normandy here. So other samples here to show you that it's really a very important technique used in west of France, and as well for very small buildings. We've got some very, very small other area in France where we can find that sort of buildings here in Vendée, so center-west of France, close to the sea. So small, very small buildings here, built with a very sandy soil with a bit of clay. So very, and this one are very poor compared to the one you can find in Brittany or in Normandy. So it's a very, they are very, very small, small buildings, small farms. And same thing for the Pays de la Loire. So around the Loire River, we've got plenty of those cob buildings, mostly for farms, not for a living place for people. So an heritage that is really in danger because no use today. So lots of those buildings are in a very, very bad state, as you can see here. And south of France, we have also huge heritage, a small area, so less building compared to Brittany and Normandy, but very nice one, and as well some farms, so some place where people are living, so quite well maintained. People try to renovate the house properly. So an heritage that is still in a good state mostly. We can find some other area in Europe where we can find some cob building. Here some samples in the center of Germany, in Saxe-Anhalt, where you can see some huge farm as well. Other samples in earthquake area here in Italy, in Abruzzo, where you can find a lot of cob buildings still existing. And I think that they had a huge earthquakes maybe 10 or 15 years ago, and lots of those buildings looks nice after this earthquake. So we will probably speak about that a little bit later, but it seems to cob seems to be a technique which is really resilient for earthquake. Or another part of Europe where you can find a lot of cob building, it's United Kingdom, and especially in the south of UK, in Devon, where you have a very nice and a very important heritage. Even if you can't really see it, I've shown you some pictures in Normandy and Brittany where you can really see cob, because cob is not covered with a lime plaster. But in UK, most of them have the stone heritage. Most of the cob heritage is covered by a plaster, so you can't really distinguish cob and stone masonry. But a huge heritage with lots of curvy wall, sort of hobbit house that are really appreciated by English people. In the center of Europe, here in Moldova, where you can find in this area sort of cob mixed with a timber frame, so something, it's not really wattle and daub because there's not really a wattle or weaving structure on which the mix of earth and fiber is fixed. It's really a massive wall, so it's really cob, but mixed with a timber frame. You can find some samples as well in the north of Europe, in Poland or in Estonia, with a technique with it sometimes can be confused with rammed earth, because they have the small layer of fiber implemented in between a layer of earth, so it looks like rammed earth, but it's not really rammed earth because it's a wet mix which have been implemented. Just to show you the other samples of cob that is used in other places in the world. Here in Cameroon, with those shell-shaped huts, really built or by hand, and with the same mix finally, with less fiber than the European cob, but it's finally a wet and a plastic mix, which is implemented without any formwork, just shaped with the hands. Same things here in Togo, and you can feel in these pictures all the small layer of cob which have been implemented with so this step-by-step process of building, which is really one of the characteristics of cob. Can find, of course, some samples in Mali or in Timbuktu, where they use lots of cob as well. Other samples here in Burkina Faso, with the very thick walls at the basement, and wall that began to be thinner and thinner as they go higher. Some samples here in India, where they use a very clay and silty soil, so lots of cracks, as you can see on these pictures, lots of cracks due to the shrinkage process and because of the lack of fiber in the mix. I just show you this picture here, which is not really cob, not really rammed earth. It's in between. It's a sort of a hybrid techniques, because it's a very wet rammed earth and a very dry cob, and it's something we tried to use in some modern experimentation about cob here in Normandy, and I will show you some pictures. We probably make the link with these samples here. Other samples here in Madagascar, where cob have probably been imported by the colonial period. It's a huge building as well, built with these cobs, and of course some pictures here from Yemen or Arabia Saudite, where you can find very nice building made with for some of them made with cob, so with 3, 4, and sometimes 10 stories. So a very high building, which prove that cob can be used to build in a higher and high walls. Here are samples in Afghanistan, where you can find like Iran, a lot of cob buildings, or even in earthquakes area. And here are samples from America, where cob was probably one of the most used techniques, probably with adobe, but adobe has been imported by the Spanish people most of the time, and cob was the indigenous techniques used here. So if I'm coming back to now the cob Bauge project, and this project, result projects on modernization of cob building, we made this first statement that cob was used in different way to implement it, but most of the time techniques that require lots of human power, a very heavy technique to build a very big and big wall, very sorry, I don't find the word, with a big thickness. So a huge amount of material to implement, which make the techniques not easy to use in a modern way. We also see or agree with the fact that all those techniques were really very well represented in Normandy and south of UK, where the partners of the project were living and working. So this project, this Cobboche project, is a project which is a project of 6 partners, and the 3 historical one were the University of Plymouth, the School of Engineer from Caen, ESITC, and the Regional Park. And we designed this project, the 3 of us, and then we added some other partners. So the English Association IBUCAI for Earth Building UK and Ireland, the University of Caen, and a company, a private company, Hudson Architects, which joined the groups, and the 6 of these partners agreed to work on this project because of this common heritage, this common COB heritage in Normandy and south of UK. If I'm looking a bit about modern experiments on COB building, there's, if you put that on a Google, you will find lots of that kind of curvy wall, handmade wall with COB, because it's really a technique that was really used by the counterculture and all the people involved in this movement, especially coming from the US in the 80s, and where they built a lot and write a lot about the COB techniques and spread these techniques, especially in the English speaking countries, and so lots of those COB building appear from this period. In France, we had a different experience, not really coming from this counterculture movement, but coming mainly from heritage. Few samples like this one from a builder in Brittany, where he reproduce or try to modernize the technique that I've shown you, called gazon. So using lots of volunteer on his building, on his site, he used his techniques, cutting some small bricks and implemented them in the formwork to be sure that the wall will be built in a straight way and in a safety way for the volunteers. So he adapted these techniques, trying to build some new buildings. But most of our company in France or in UK were conventional companies working on heritage, trying to preserve and renovate heritage, and they just try to find new way to build using less human energy and trying to use more engine, trying to use formwork, to introduce the use of formworks, to reduce the amount of work, to reduce or to avoid the cutting phase of the wall, which is really a painful process. So we had some old experiments, like the first metal mesh formwork we produced in Normandy here on the left with a builder in my area. He produced this sort of small formwork here. Other guys tried to work a bit like the technique that I've shown you in Himachal Pradesh, where it was this hybrid techniques between cob and rammed earth. So they tried to use full formwork but try to reduce the water content of the mix to have something drier than the traditional cob, to allow them to build 2 meters high in a day. So without this step-by-step process and waiting 3 weeks between each layer. And on the right, another sample of modernization introduced by a cob builders in Devon, in UK, so, south of UK, where he used the digger to produce his mix and to implement it on the wall. So he managed to really reduce the amount of manpower on his project and to build very quickly. So it probably go twice faster than the traditional techniques with that kind of tool of engine on the building site. So something really interesting to see that we had some experiments on modernizing the traditional cob techniques, so which give us confidence in the fact that a research project was interesting to improve the process and to improve as well the thermal properties of cob, because it's mainly as well something really important here in Europe. In Europe, we have more and more thermal regulation that are asking us to be more efficient regarding the energy consumption and the CO2 emission during the building process. So we try to reduce the use of energy by insulating the building. And cob is, even if it has earth has good properties regarding thermal mass, regarding the regulation of humidity in the building, in the living rooms. But if we just looking at the thermal resistance, cob and earth are not really good. So in a legal point of view, we can't meet the thermal regulation out there in France and in UK. So that's why we tried to put all those things together in this cob-bosch project, trying to improve the building process, to reduce the painfulness of the building process, and try to improve the thermal performance of the mix. As we had a mix of earth and fiber, the idea was to see how we could put enough fibers in the mix to have something which could be load bearing and insulating at the same time. It was a bit it was an hypothesis we had in mind at the beginning of the project, even if it was not really realistic. We knew that, but it was our first hypothesis. So to start this work, we have try to find different materials, to test different materials, to test different fibers and soil to produce the mix. So here, just to show you the variety of the soil we have studied, some very rich clay soil, some sandy soil, some stony soils, and clay silty soils, to have a very good overview of what could be done and achieved with that kind of material. We first start to make a series of tests to understand the relation between fibers and water and the soil. So a first series to understand the performance, to understand the method of making the sample, and for that we ask for builders to show us the good viscosity or plasticity of the mix, to be sure that all the scientific in the labs will reproduce something which really meets what the builders are using on the building site, and which allow them finally to reproduce always the same materials in the labs. Those first samples, we test them, even if it was not really really well in a scientific point of view, because we just produced one sample for one mix. So we should have produce three samples to have something really relevant in a scientific point of view, but just here to have a first approach, a first overview of this relation between the amount of fiber, the amount of water, and the amount of soil. To have a first overview, we test those small samples, which allow us to see that it was really utopic to have just one mix, good for installation and good for load bearing, all the to support all the load of the building. So we continue in this approach of two different mix, and define together with the builders and the scientific, we define the good mix and produce some tests which will allow the scientific to reproduce those materials in the labs for the studies. So after we had made this first study on the soil, we choose to just keep two different soil from UK and different soil from France. One of those, two of those soil to produce the insulating mix, so the light earth, you can find here in red, and we choose 4 of the soil to test the mix for cob, for the load bearing part of the wall. So you've got an overview here of those soils. So they're very clay soil for the insulation, and well-graded mixed for well-graded soil for the cob. We've tested as well the activity of the soil, and some of those soil we use for the lighters were very active clay, as you can see here, which give us some issue on our first prototype we built after this first part of the study. Regarding the fibers, we have tested 4 plants which represent 6 fibers. So first, wheat straw, as the fiber which is used traditionally in cob buildings. So it was our reference to compare the other fibers. We tried to use reed, which was used in Devon and in Normandy, in the thatch roof and so on. So we had these plants in several areas in the country. We tried to use to study hemp in the 2 states, and the raw hemp straw and hemp sheaves. So just after moving the fibers from the plants, and same things for the flax. We use flax straw, so the raw flax straw, and the flax sheaves. So just after moving the fibers from the plants. And you can see here, you can see here that just regarding the density, the absolute density, the wheat straw is the poorest material we study. So mean that the other one could have a better properties in a load-bearing point of view. And we test them though regarding two other questions, the water absorption. We study that because if you've got a plant which absorbs a lot of water, it means that you need to add more water to still have something very plastic. So the less it's absorbed water, the less water you will have in your mix, and probably the less drying period you will have at the end. So that was the idea behind that that study. And we study as well the tensile strength to have an information about elasticity, resistance, and the tensile strength, of the cob, and as well it could have had an influence on the compressive strength. And here, as you can see, wheat straw is once more the poorest material we found. Reed and flax had a better properties for that. Regarding thermal properties, we use the heat flow sensor method to test our samples. And here the experimentation plan we reproduced because we didn't have time to test all the samples. So the scientists produced this plan to just test few possibilities and can extract from that plan, and the results of those studies can anticipate the behavior of the other mix. And here are some of the results regarding the compressive strengths, where we managed to have some good resistance regarding the use of flax and hemp straw, around or more than 1 megapascal, so something really interesting. And once again, if you're looking in the spreadsheet, by the place of wheat straw, we had very, very bad results with that. Just here to show you that it's really fit with or meet the previous results. Here results coming from a study from Christoph Ziegert in Germany at the beginning of the year 20,000, where he had some results really close to what we produced here. Regarding the mechanical resistance of compressive strength of the light mixture, of course, we've got some very poor results, but it's not the load-bearing part of the wall, so not really important here. So the results we obtained with this first study prove that flax and hemp allow us to gain on a mechanical point of view, mechanical resistance, compressive strength compared to the straw traditionally used. The fibers content around 2.5% impairs mechanical strength. The strong clay has not really a huge impact on the compressive strength, and if we have finally a very low clay content soil, finally this experiment shows that just using a different fiber could allow us to improve a bit the compressive strengths of this poor material. Regarding the thermal resistance as well, the scientific produce a plan for experimentation here with just few samples with 25% and 50% in weight of fibers in the mix, and we had some really interesting results. Here you can see that even if the soil were exactly the same, even if the clay content was exactly the same, the water content was exactly the same, we managed to produce samples with very various density, meaning that for light earth, the implementation process has a very huge impact on the density and, of course, on the lambda value results, of course. So it means that for the light earth, more than the proportion of the materials, it's really the way that builders will implement the material, which will produce the good properties of the wall, the good thermal properties of the wall. With a light mixture, so with load-bearing mix, we also test them in a thermal point of view, but as you can see here, very few impact, and even if even if the proportion were the same, the density was very close. It's really on the light earth that we have a big issue with the implementation process. So here, just a graph to show you the where we had our results regarding the light earth and the load-bearing cob. So that allows us to make some simulation to see if that's kind of material, so a very dense material for the cob and the load-bearing wall and a light earth, if it could help us to meet the regulation. So within that sort of theoretical calculation, we managed to see that we with a wall of 60 centimeter thick, 30 centimeters of cob, 30 centimeters of light earth, we managed to have a thermal resistance of 3.8, so a U value of 0.26, which allow us to meet the English thermal regulation and help us in the French regulation to meet the performance that is required. So something really really encouraging, which push us to go deeper in the building process. So for that, as you've seen in the first study, we knew that just one mix was not the solution, but two mix, one load bearing, one insulating mix was necessary. So we tried to experiment with builders. Is here with Becky Little, builders from Scotland, during a training course near Lyon. We tried to produce a sample of wall, of scale one wall, implementing those two mix to see how it will react. And this first wall here in the middle finally dried pretty well, and no separation between the two layers, even if it was two different density, two different materials. It seems to stick very well. So we tried to produce other samples with the soil study in the labs. So the third wall you can see here on the slide, we use the soil study in the lab to produce a few scale 1 samples and see if it works in the same way. So it was a first step, just trying the building process, but it doesn't really give us some information about the real performance of the material of the building, and didn't give us some information about all the building process with that new way of building with cob. So we decided to try a larger scale building, which was a very small one, just 13 square meter building. We decided to build here in the marshes of Cotentin, a small building but with a lot of difficulties to test different building details. So for that, we tried to improve the formwork. So if you remember those first pictures, so a very artisanal. Sorry, I don't find the word in English. Handmade. Yes, thank you, Matthieu. Handmade formwork made with mesh, metallic mesh, and metallic framework frame. We tried to use aluminium formwork used for concrete, and with the company, the producer of those formwork, we tried to modify them to include a metallic skin instead of the plywood. Those formwork were more were lighter than the previous one, the first one, and were as well interesting because most of the modern or huge building company using concrete were familiar with that kind of formwork and were able to use them very easily. Just to introduce the building process, of course, as we need to have a very a wall which will work well regarding the thermal performance, we needed to have a way to produce a constant layer of light earth. Always the same thickness of light earth. So we decided to produce an intermediate formwork. You've got the design, the drawings here, and the symbol produce, which allow us to first implement, the cob. Can see on the small video here, just using the bucket of the digger, we could put the mix in the formwork, and then the builders just had to walk in the formwork. So really less painful than using a fork to implement the material. They just have to walk to densify the mix and avoid the gap in the mix and the wall. So quite easy process for that. And just moving this intermediate formwork, we had a gap here that we could fill with a light earth. So we proceed a bit like rammed earth finally, with small layer. For rammed earth, a layer is about 8 centimeters high. Here we could build 20 centimeters high, but we use that very small layer, but small layer process. The light earth, same thing. Sorry, a bit too noisy. So the same process. We just have to gently ram the lighters to densify it and to make it sticking with the cob. So it allows us to have that kind of wall here with a section you can see on the right. It allows us to have a good harping. I don't know if it's a proper word in English, but you see the layers can really connect together. And we obtain as well a regular layer to ensure both the load bearing and the insulating capacities of the wall. For the rest of the detail, most of them are really identical to the one we use for traditional cob. We just had to adapt a bit those detail, but it's the same thing. Some stuff to hook to anchor the wall, to connect the roof structure on the wall. So very quite the same thing, just some different things regarding the floor, because of course without any formwork you can put all the beams as you're going up on the top of the wall. So you implement your floor at the same time you build the cob walls, but with the formwork it's not the same process. So we had to adapt the system, and so we tried several details and find the best one, or the quicker one or easiest one. We had also to study some way to fix all the windows openings on the wall. So we tried several places to fix the openings. We tried to fix them on the lighters. We tried to fix them at the junction between the lighters and the cob, and we tried to fix them inside on the cob directly, and try to see as well how we could achieve a good airtightness properties on the walls to have a very good global insulation or thermal performance on the wall. So that kind of plastic mesh implemented in lime plaster, in the internal or external lime or earth plaster, works pretty well. And we managed we made some tests, some blower dot tests to see if we managed to achieve the rule regarding that in the thermal regulation, and just plastering the wall, just filling the small cracks or small gaps in the cob wall. We managed to pass the regulation quite easily. We measure a lot of things during the building process. We try to measure the organization of the building process, of the construction. So here are samples of the time of implementation that we measured, showing that the first layer we spent 2 hours per square meter, and then the fourth lift, just using the digger, we managed to reduce by 2 this time of implementation. And then we've seen that building on a 2-story building mean that we had to use different engine on the building site, and it took us a little bit more time, 8 hours per square meter. We have measured the drying process. So the School of Engineers put lots of probes in the walls to have a good survey of the drying process. And we had few issue with the formwork, but mostly because of the lighters and the clay content of the lighters. We had some small issue, some cracks in the wall, and a deformation of movement in the wall, mainly due due to the clay activity of the soil we use for the lighters. But what is interesting here is the fact that when we try to find a solution against this problem, we've used some geogrid. You can see here on the right pictures. And these geogrids works pretty well in the corner, in reinforcement in the corner. And finally, it's something interesting regarding the earthquake resistance. We've seen after that kind of geogrid was often used in rammed earth to reinforce rammed earth structure regarding earthquake resistance, and finally it's close as well to some US regulation on COB buildings regarding earthquake. So finally, these techniques here I show you can be useful if you want to try this technique in Turkey. So this is the prototype finished here. It's still in place after 1 year, so it seems to work. Cross the finger. But after this first experiment, we decided to build other building, of course, and trying to see if we could manage to solve some of the problem we've seen, we observed in this first prototype. So here in Plymouth, they decided to build some test wall in the lab to measure the movement after loading the wall. As you can see here, they put lots of sandbag on top of those walls, and they as well produce a huge pressure with metallic stuff on the top of the wall, just to see if they could achieve the resistance of a two-story wall with all the load that the wall which have to support. And that's they produced that funny pictures here, but they managed to without any cracks and without collapse of the wall, they managed to put the equivalent of two African elephants on top of each of those walls. So seems to work pretty well. I don't know. They should have tried to break those walls, so go further in the load bearing of those walls, but I haven't got the result actually. So they did that helps. That helps them to be more confident, and the University of Plymouth decided to build a classroom on the campus. So they built their own prototype, bigger than ours. So they tried different sort of formwork, just a wood frame here with metallic mesh, and try to use some curved formwork to produce some curved cob wall, because as I've told you, English people like the curved, the curvy wall, the curvy cob wall, and they're really attached to that sort of shape. So they decided to try that, and they built quite in the same way. Just using less engine on their building site, lots of manpower because of the location of the building, which didn't really allow them to circulate around the building with a digger. So most of this building was implemented by hand. So here the building finished. And they implemented some measurement as well. So lots of sensors in the building to in the walls to measure the drying process, but as well the heat transfer in the wall. And they decided as well to measure the shrinkage of the building with a disto laser, and they've seen that there was no deformation of their wall. So just the fact that we use a very rich clay soil and reed sheaves for the light earth in Normandy. Here in UK, they decided to use M sheaves. They had a very rich and active clay soil as well, but just the fact that they used M sheaves instead of reed sheaves, they managed to avoid the deformation of the wall. So it was the problem, the issue we had in Normandy in the first prototype was mainly due to this bad connection finally, or bad mix using reed sheaves and clay soil, just using less compressive fibers like hemp allow them to avoid this issue. But we still have a huge shrinkage. Sorry, yeah, I forgot to just see that I forgot to translate this slide. But so you can see the point that's showing the roof going down during the drying process. No deformation, but a very huge shrinkage. So some things to have in mind when we built, especially regarding the windows. So here the building finished and used actually since 6 months now. They're using this classroom. And finally, another project designed by Hudson, one of the partner, close to Norwich in the southeast of England, where they managed to find a client to build a dwelling here in Fakenham. So the drawings here, so it's a house of around 80 square meters, built with this technique. So some details of the plinth here. An overview of the building site, and they decided to use a very different formwork. So building a formwork inside directly at the good level and shape, and just trying to move the external formwork as far as they were building higher on the wall. So here's some view of the building site and the process. They built in the same way as Plymouth. They didn't really take care about the organization of the building sites. They could have used a digger if they had put the scaffolding inside the building and not outside. So they lose some time, they lose some energy, human energy, by this mistake. But finally they managed to build all the wall, and that's the state where they were at the end of March this year, or end of November, to be more honest. So they had to stop the building process during the winter, and now the cob walls are finished and are drying, and they hope to be able to make the internal plaster inside by September. No. Just some pictures taken in March, end of March. So regarding this cob project, you can find lots of studies, guide, details, training video on the website of the project. You can download them for free without any problem. And just to finish and make a link with one of the question for you in Turkey after this earthquake. I've tried to find few references of study regarding earth and earthquake and COB and earthquake. So I managed to find some few things really interesting, and I will send to Matthieu the PDF of this presentation, so you will be able to have access to those links and those studies. But what I've found, even if I'm not really a specialist of earthquake resistance, but just having a very quick look, to be honest, but having a look on the conclusion of those studies, most of them are pointing that COB is quite good at regarding earthquake resistance, mainly due to the amount of fibers in the mix, which have an impact if we compare that to rammed earth, for example. It have an impact reducing a bit the compressive strength of the material, but the fact that we have lots of fibers in the mix finally increase the properties of the material regarding elasticity and COB walls. In some of the texts they made, COB walls are not collapsing, they're cracking, they're deformed, but they are not collapsing quickly. So it seems to be one of the earth techniques which have the best results regarding earthquake resistance. And just to finish, some samples which make a link probably with what I've shown you regarding this COB Bosch project. But here, just a drawing, detailed drawings coming from US regulation on COB building, sorry. And you can see on the right some details about the way they increase the properties of COB walls in earthquake area, using some reinforcement, vertical reinforcement in the COB, and some geogrid or stuff like that to reinforce in a horizontal way, so very close to what we introduced in the COB Bosch project in this first prototype and in the corner. And another pictures and which remind me a lot of discussion I had with Wilfredo Carrazas and with Alexandre Doulin from Crater. They produce a guide on wattle and daub in seismic area. So it's wattle and daub, but finally they produce a wall which is very close, just regarding the thickness of the wall. I think it's a wattle and daub wall around 20-25 centimeters thick. So just the half of the thickness of a real COB walls, but what the detail they produce to reinforce the wattle and daub with bamboo, vertical and horizontal structure in bamboo. They call it wattle and daub, but we could probably easily build the same thing with COB with wall of 40 or 50 centimeter thick without any problem. So just using that kind of bamboo reinforcement implemented in the COB, we could probably achieve a very strong wall regarding that. And I think, yes, it was my last slide. So thank you for your attention. And if you've got some question, I'm happy to answer them.
Thanks a lot, François, for this presentation. It was really interesting and full of very valuable information, especially on this COB project and all what you have done, what you have tested, how you have tested it. So thanks, and yeah, finding those articles will at least help us to directly go to the source. So instead of looking around. So thanks a lot for those information. And I didn't know it was a IRC code for COB. I knew about Strobel, about light clay and so on, but I didn't know for COB it was already written. So I will have a look through it. So thanks.
And
for
they had as well made some very recent test on fire resistance as well. So I think it's not yet included in the code, but it's they made the proper test for that.
Okay, nice. So that I will go for it, because there are always very interesting information, especially about earthquake in those areas. So thanks a lot. So yeah, before I ask questions, that I have a lot of questions about some details on the construction that were interesting to see, I would ask if other people would have questions. Sema, Hanım?
Thank you for the presentation, and so inspiring and also encouraging. I'm planning to dive into this field in the near future with our students, and hopefully with the supervision of Bilge Hoca. My question is, how you communicate with the people that these traditional techniques can bring comfortable comfort, and they will be durable as the reinforced concrete or other techniques. So how you communicate with the public?
That's part of the job we have to do now. So we started to make this study just participating in 3 home fairs here in France, with students in communication and trade and so on. So we built a questionnaire, and we asked people who were in those fairs to build or to buy a house or things like that, and we just asked them if they were confident with earth, and showing them some sample of traditional cob wall, and we were really surprised to see that well, 16% of the people who answer earth were quite confident with earth, and 2.5% were ready to build with the material, but they didn't add all the information, of course. So it's of course it's a theoretical thing, and we know that, but even if it's 2.5%, it's really more than the 0.01%, which is actually the market, the earth building market in France. So it proved that if we explain and show people that we can use those materials, they can be confident in it, and we can increase the amount of building using those materials. No, the other thing is to trying to find a way to show them know that we achieve our goal with this study. We need to go and meet those people once more. We have to be on building fair, to have our neighbor with polystyrene and concrete blocks, and just showing that earth can be used. So it's something not easy to do with earth builders. They are not really happy to be in this place, but they have to. We've seen as well that we were on a very huge fair in Paris, Batimat, which is one of the most important construction fair in France and maybe in Europe. And same thing for our English partner. They participated in a huge building fair in London, and lots of engineer architects are really interesting in the process. So we know that we can probably if we speak more about that, and if we show more sample using those techniques, we will probably manage to have a better understanding of the material and acceptance of the material. But it's something we know that it is something that will take time.
Thank you so much.
Thanks a lot, François. Anyone else have question to François about the project? Yeah, Merve.
Hi, I have a question, if possible. Yes, my name is Şafak Ebesek from Istanbul Technical University. And do you listen me?
Yes.
Yes, okay. Do you have any observation about the maintenance issues of this kind of buildings, especially atmospheric and mechanic and chemical other effects?
Regarding the thermal properties, if I well understood your question, regarding thermal properties, we are surveying those buildings, so there are still some probes and sensors which are working actually and giving us some data. So it's I don't have the latest results, but it seems to work as we plan. So very good comfort quality during summer and good quality during winter. But we will have probably more results in 1 year, probably, to be honest, because we just have actually a bit more than we are around 8 months of measurement after the building are finished. So not enough measurement to have a real and good overview in a scientific point of view. Regarding mechanical properties, we still have some survey on those buildings as well. So actually nothing really appears. And regarding chemical stuff as well, we have some air quality probes inside and outside the building, so which allow us to see if using earth has an impact on the air quality regarding fibers, but as well VOC and so on. So we measuring that, but I can't tell you exactly what are the results actually. It's
Thank you very much. Thanks for your answer. And we are waiting for your observations, please. Thanks.
Everything will be published on the website with probably some delay between the results, the scientific publication, and when the university will have their scientific publication, we will put that on the website. So you will have the results.
Yeah. Sure. And I think also, François, one of the questions was also about the maintenance of these buildings, if they need any maintenance because of rain or snow, or if there is any problem of, because that's one of the main problems facing the earthen building in Turkey. Actually, it's about maintenance and keeping them safe and healthy.
So, regarding the maintenance, we are in a windy and rainy area. both in Normandy and in UK, in Plymouth. They are very close to the sea, and we are at 30 kilometers from the sea, but in a marshes, so without any trees, so lots of wind in this place. So what we've done regarding the protection of the light earth, which is outside, of course, to keep the thermal mass inside the building. So outside at its light earth, it's a very fragile material. So we protect it with a lime plaster, 3 layers of lime plaster, so a very rich lime mortar for the first coat. Second coat just lime and sand, and the final coat contain a bit of clay needed in it to produce this brown color you've seen on the prototype. The UK building, it's a ready-made lime plaster they use, so that's why it's a very white plaster, but it's lime as well, and it seems to work pretty well. We made a study. I'm not sure that the results are on the website. Maybe they put it a few days ago, but I'm not sure. I will check that. But we produced some samples of different lime plaster on sampled on wall light earth samples, and we put them in Plymouth on the west wall, so just in front of the wall of the wind and rain, and they put some probes to measure the impact of those render regarding the humidity content in light earth. And of course, the best way is to let the light earth without any render, so it's allow the light earth to dry very quickly, but of course you have some erosion, so the lime render is necessary to protect the wall, but it seems to work well actually. And inside we prefer to use earth plaster because it's more interesting regarding the maintenance. Lime plaster are not easy to repair, but earth plaster, if you just rehumidify the plaster, you can renovate them quite easily. And we want to show that using earth is possible inside, and it's a good material for that. So inside we know that we won't have a lot of problem with maintenance. We know that those earth plaster are quite easy to renovate, and lime plaster, we have now 25 years of experience on lime plaster on traditional cob wall, and most of them are working pretty well. So we are quite confident with that.
Okay, thanks a lot.
So just to finish that, we will have a maintenance, like every building need a maintenance, but probably every 20 years, probably.
Okay, yeah, that's better than every year.
Yeah.
Thanks a lot for it. Merve, I think you had a question.
Thank you very much, François, for your presentation. I have 3 questions, by the way. One is, as you told, about the shrinkage of the earth wall, cob wall. When you finish the wall and you use a plaster outside, to render with lime plaster, for example, what happens when it's shrink? Is there any cracks on the plaster? My first question.
So that's the main issue with it. This technique, it's the drying process. It means that you have to wait before you make all the finish surface, before you plastering and so on. You have to wait that the drying process is not really finished, but the shrinkage process is finished. So it means that you have to wait probably 6 months before you can put the lime or earth plaster on the wall. Of course, it depends on the weather condition of this area. But we know that I think that Plymouth have implemented their earth and lime plaster 4 months after the finishing of the wall, and they didn't have any issue with that. So the shrinkage was enough. The wall were not dry, but the shrink process was finished.
Great.
And it's because they had this survey with the distola there, so they were able to see that the shrinkage was really important at the beginning, but started to go lower and lower, and was quite finished. So they decided to implement the plaster.
I think with the hemp, you said in climate, the shrink is low. No?
Sorry?
With a hemp.
When you use a hemp instead of reed, the shrinkage in the wall was.
I mean, it's not really the shrinkage. It's the we had an issue with the first prototype because of the light earth. The light earth with the shrinkage of the light earth, which was really important due to the use of reed. The shrinkage deformed the cob wall, so it shrink outside. It dry faster outside. So a huge shrinkage on the light earth, a drying process that fixed the cob inside, and so the connection between light earth and cob was still a bit fresh, and so lots of deformation due to that. And just the fact that they use hemp sheaves instead of reed, the fiber was not really compressible. Finally, the reed, when we crushed it, it had broken the tube, and finally those sheaves could really be compressed, and so with the activity of the clay. Yeah, but with hemp we didn't have that issue. But after that, you've got all the shrinkage process we still have with cob because of the amount of water in the mix, and this shrinkage is about 2%.
About natural park you are working, you still work there, as I understand, as a your park was your park the coordinator of this coverage project, or you entered to this project as the architect?
So I'm an architect, but working for the park. Most of the time, I'm just giving some advice for the owner of traditional cob buildings. So I'm mostly working on renovation. But as we wanted to develop the use of modern earth techniques, we decided to be involved in this project. And just Steve Goodyew from Plymouth, Mohamed Boutwil from SITC, and me, we designed the project around a coffee in the Plymouth University, just drawing or giving the idea of the project, and then we added other partner on that. So my job is to try to spread all the results of these techniques, to train architects, engineers, builders to use these techniques now in France. So I give him some conference or course in a School of Architecture, School of Engineer, and trying to train builders.
Great. Thank you very much.
Okay. Thanks a lot. Is there Any other question for François? No, I think it was a really good presentation. I know you have a lot of work. I just had a really slight, small question on one detail I just saw from the building that is under construction by Hudson Architects. And I saw that they were having very large beams supporting the weight on the roof. So the weight is concentrated on one point of the wall. And I was wondering if it was something possible with COB, because usually when we try to spread the weight equivalently on all walls. And so I was really wondering about this issue.
It's something which is traditional in COB or in our heritage. Most of the loads are really concentrated on huge beams, but normally we have behind the beams we have a piece of wood that will spray the load on a higher surface. So it's in this case the engineer have designed that detail, so you can't see them on the picture, but you have a piece of wood that will spread this load.
Okay, thanks a lot. And okay, so yeah, you have a lot of work, as you told us before, to finish. So thanks a lot for this, giving us all this time and explaining your projects. And so we wish you good luck to finish all your translation work and conclusions. And I hope we can meet again for some other work another time. Thanks a lot again, François, for tonight.
You're welcome. Thank you for your attention. And if you've got other questions or want to see other things, just ask. Okay. You've got my mail address and so on. So
thanks a lot.
Don't hesitate.
Okay. Bye-bye.
Thank you. Bye.
Bye.
Thanks a lot.
Thank you.